Alright, so this is lesson 26 for Algebra 2, or day 26. This is week 6. Wow. Okay. So today you're going to be simplifying radicals to write complex numbers. So, and the standard is in, just so you know, this is one of your standards. Now we're in Algebra 2 territory. It's a very simple Algebra 2 standard, but now that we kind of know our radicals, now we could start working here. So in Algebra 1 and before, even last year when we had, let's say, the square root of -4. Actually, let's just start with this. Square root of 4, everyone, what is the square root of 4? 2, right? Because we could say the what times itself is equal to 4? 2. What else times itself is equal to 4? No. What else times itself is equal to 4? -2, right? Right? So 2 times 2 is 4, and -2 times -2 is 4. Good? Okay, so everyone following how we take a square root? Now we've been working on that, so what happens if it's like a square root of -4? What times itself is equal to -4? No, what times itself is equal to -4? Nothing, right? Is there anything that we can multiply times itself to get -4? No. So then in Algebra 1, we'd say this was no solution. Okay? And we didn't really talk to you about complex numbers or imaginary numbers. Okay? Today we're going to talk about imaginary numbers. So in Algebra 2 and moving forward, when you have a square root of a negative number, eyes up here, pretend that the square root of a negative is like saying the square root of I times I. I is an imaginary number. Okay? So whenever I see a negative sign, I'm imagining that it's really just I times I. Okay, what's the square root of I times I?
Squared.
No, what's the square root of I squared actually? What's the square root of I squared? I, good. So then we would bring out an I. What's the square root of 4? 2, right? Is there anything else left inside there? No, so then we would say our answer, or this would simplify to be 2i, which is an imaginary number. Okay, this is an imaginary number. Imaginary. Which is a different set of numbers. Before we used to have real numbers. Now we have imaginary numbers, okay? So before we had real numbers, now we have imaginary numbers that we're going to add to it, okay? Okay, makes sense? Okay, so let's just have a little group discussion on how we could deal with a negative and a radical sign. Ready, set, talk. So if you're on the video, these are the steps. We find the index of the radical. Is the radicand positive or negative? Convert the negative sign to I times I. Factor the radicand, simplify, and put the answer in A plus BI form. Okay? So, looking up here, let's do a few of these together. Number 1, we have simplify. We want to take this. What's the square root of -32? Okay, let me teach you what to do with this now, okay? 1 and 2, just eyes up here. Good, I like the way you're thinking. There's nothing no real number that's the square root of -32. So now we have to think like, okay, well, how do I deal with this? So we have a negative sign. Remember, I just taught you it's like saying I times I. And then 32, what's the largest perfect square in 32? Thank you. Okay, let's focus on these answers. What's the biggest perfect square that goes into 32? 16 times what?
2.
Good, thank you. Okay. Okay, so what can I take out of here? Good, the square root of... Okay, let me talk, okay? Square root of 2 stays inside, so we got 4i rad 2. And then I asked myself, can I do anything else? No. So this is the simplified form, but this is an imaginary number, okay? So I need to make this a complex number. So there's 2 parts to a complex number. There's a real part, and then we're going to add a imaginary part. So we want to make sure we write our number down in two pieces, okay? So we know what the imaginary part is. The imaginary part is positive 4i. I'm just copying this down, rad 2. But is there a real part? No, there isn't. So when there's nothing that's there, we would put 0, because 0 represents nothing, right? So this is our final answer. This is the correct final answer, is 0 plus 4i rad 2. Okay? You have to have both for this to be a complex number, okay? Makes sense? So what did I do again? Wanted to simplify. I know that I can't take a square root of negative 32, so I changed my negative sign to I times I, or I squared. 16, or 32 becomes 16 times 2. 16 is a perfect square. Square root of 16 is 4. Square root of I squared is I. And then rad 2 is, we bring that down. And then in our answer we need to have, for it to be a complex number, we need to have a real part and an imaginary part. So we're going to put 0 as a real part because there isn't one. And then 4i rad 2 was our answer to bring that down. Okay, number 2. I's up here still. No one's really writing this down. Okay, number 2. We have square root of negative 18. I know that there is no square root of negative 18. So I have to change this negative sign to I squared. 18, the largest perfect square in there is 9. It's like saying 9 times 2. So we got I squared times 9 times 2. And then we have plus 7. This is a real number on the outside. So I'm going to leave that alone. Then I simplify my square root sign. This is like saying square root of I squared is I. Square root of 9 is 3. And then we still have 2 left on the inside. Bring down the positive 7. Okay? I can't simplify this anymore. Now I notice that my imaginary number is first and then my real number, the constant, is second. I want to flip the sides of where it's at, so I'm just going to put the 7 in the beginning. And then this is a positive 3i rad 2, so I'm going to put positive 3i rad 2 here. And that's it. That is number 2. Questions on numbers 1 or 2? Yes, sir?
So for number 1, you weren't given the real number, so you just put a 0 there?
Yeah, that's right. Yeah, because if there was no real number, what represents nothing or no? 0. So you just put a 0 there. There's no real numbers, so we put 0 real numbers. Yes?
So every time we deal with something like rad 2, we always have to put it to imaginary.
No.
If it's a negative.
If it's a negative, yep. You don't always do this, like the problems we've been doing all, the first or last couple weeks. Those didn't have negative radicands, so now we do, so we have to put in imaginary numbers. Okay? Let's hear some, yes? Yes, it does, always have to come first. That's why I wanted you to make sure you put the real part first. It has to go first, okay? Alright, so now you can talk. Let's have 1s tell the rest of the group, teaching them how to do number 1. 2s tell the rest of the group, teaching them how to do number 2. Ready, set. Continuing on. Oh. Okay, continuing on here. Okay, should say simplify. Number 3, let's all do this in our notebooks and then write your final answer in your on your iPads, okay? So it should say the square root of negative 4, square root of negative 4. One you should have had, oh man, this one. It should say square root of negative 4 we can't do, so we have to take a negative sign, make it I squared. So we got I squared times 4 on the inside here. Square root of I squared is I. Square root of 4 is 2. So that's the simplified form. This is an imaginary number, so we want to put a real number in front. There isn't one, so we put 0 plus 2i. That's your answer. Okay? Compare your answers to everyone else in your group, because some people did make mistakes. Talk about where you made a mistake. Okay, next one. Number 4. Number 4. Number 4, we got the square root of negative 12. So in this example, we have a square root of negative 12. We can't do that, so we have to take the negative sign, turns into I squared. 12, we ask ourselves, what's the biggest? I's up here, what's the biggest square? Perfect square? 4, right? So this is like saying 4 times 3. Square root of I squared is I. Square root of 4 is 2. Square root of 3, there isn't one, so we leave that on the inside. Then we ask yourselves, is there a real number that goes with it? Nope, so we're going to write 0 plus 2i rad 3. Okay, some people have made mistakes. Talk to your neighbors about it really quick. Explain where you made a mistake and how you fixed it. Okay, continuing on here. Number 5. Number 5. We're going to simplify, right? And, of course, we're going to make sure that this is not all the way across. Sorry. It's supposed to say... Okay, so we're taking the square root of negative 16 and then we add 4 to it. What's the final answer? Make sure you're working this out. Here are your answers to mine. So square root of negative 16, we don't have one, so you have to take the negative sign, turn it into I squared times 16. Oh, that's a perfect square, right? And then bring that plus 4. What's the square root of I? Or I squared, it's I. Square root of 16 is 4. And then we got plus 4. This isn't in the correct format. We want to put the real number first, so we got 4 plus 4i. That's your correct final answer. Okay? Make sense?
Yes.
Okay, last one, number 6. Go. So on this one, there is no square root of negative 36, so it's going to be I squared. We're going to change the negative to an I squared. Square root of 36 is still a perfect square, square root of 36. So plus the 2 on the outside. Square root of I squared is I. Square root of 36 is 6. Plus 2. And then we could say that this is like saying 2 plus 6i. Right? This is the correct complex number form. Okay? That's it. That concludes the lesson.